All right, well, I'm recording this at home. My two children are sitting on the couch. They'll probably start beating on each other soon, and you'll hear screams. I can barely talk without coughing, so we'll see what happens. But we're going to take a few notes on compounds. Stop staring at me, Anna. So here's the first question. Vegetarian is sitting next to a meat lover at a barbecue. They're given this big, juicy hamburger here. What's going to happen to make both of them happy? So write that down. Take 30 seconds, write that down. All right, I don't have 30 seconds to wait because I'll probably start coughing. So we'll just go ahead and go forward and see what happens. So the most logical thing that's going to happen is that the vegetarian's going to give the hamburger to the meat lover. All right, let's look at another scenario. You love meat and you're at a barbecue where there's only one hamburger left. The guy sitting next to you loves hamburgers too. So what is the only way that both of you can be made happy, right? So you're going to make, I don't know, remember we used to have the Burger King kind of scary guy? Maybe he looks like him. And this guy. Oh, maybe this little kid. He probably wants a piece too. And this guy, he may want a piece. And maybe this guy, I don't know. Is that a lady back there? I can't really see. But, all right. So if they both want the hamburger, what are you going to do to make everybody happy? Well, you're going to share the hamburger. So the question is, what does this have to do with chemistry? Well, vegetarian and a meat lover, they're both given a big juicy hamburger. What will happen to make them both happy? This is going to illustrate a type of bond called an ionic bond. And we're going to learn what an ionic bond is. The hamburger is an electron. So the vegetarian is an element with a low electronegativity, and it gives up the electron. Vegetarian is basically going to be a metal. The meat lover is an element with a high electronegativity, and it gains the electron. It's going to be a nonmetal. All right, in the case where they have to share the hamburger, that's going to be two elements with high electronegativities. Basically, two nonmetals, they're going to form a covalent compound. All right, they both want electrons, but they have to share. That's going to be called a covalent bond. So if you can remember, excuse me there, ionic bonds, covalent bonds, think about giving away your hamburger or sharing your hamburger. Those are the two main types of bonds. We'll also be talking about metallic bonds, but that's later. So this unit, which is chapter 6 in your book, deals with chemical bonding. So question 1 refers to how an ionic compound is formed. Question 2 refers to how a covalent compound is formed. It's sometimes called a molecular formula. The main thing that determines if an ionic or covalent compound will form is the electronegativity of the elements involved. So I just paused for a second to have a coughing attack, and my daughter asked me why I was talking about hamburgers, and many of you are probably wondering the same thing. So the big thing that determines what we get is electronegativity. And let's review this. Remember, electronegativity is the measure of an ability of an atom in a compound to attract electron pairs away from another atom it's bonded to. Fluorine has the highest electronegativity of 4.0. Nonmetals are generally higher than metals. Remember, the trend is electronegativity increases across the period and decreases down a group. So, an ionic compound, and sorry, this isn't really a review. This should probably be kind of... An ionic compound is formed when one or more electrons are transferred from a metal atom. All right, there's a blank there somewhere to ignore, to a non-metal atom. And positive and negative ions are formed that bond together. Remember that positive ions are called cations. Everybody stand up and make your cat paws. I'm doing it here at the kitchen table. Positive. Can you do this, kids? Positive. Oh, you should be in high school chemistry. Great job. There it is. Positive. And then remember for anion, you can kind of remember it A negative ion from the name. So in an ionic bond, there's a big electronegativity difference between the atoms. So at one point, this was, I think, the smallest and tallest man in the world. So there's a big difference in their electronegativities. If that difference is greater than 1.8, you're going to get an ionic bond between the two elements. Now, electronegativity is great, but the easiest way to really figure out if an ionic compound, if a compound is ionic, is to look at the elements that make it up. And they are just generally made up of a metal plus a non-metal. 99% of the time that's going to work, and that's going to work in honors chemistry. So a metal plus a non-metal is an ionic compound. A covalent compound, and this is like having to share the hamburger, that's formed when two atoms of similar electronegativity share pairs of electrons. And they're sharing these electrons because they want to fulfill the octet rule, because that gives them in the least energetic state. And then for covalent compounds, the big thing to remember is they are generally made up of a non-metal plus a non-metal. All right, there's one thing that you need to add to your notes is generally hydrogen plus a non-metal is generally covalent. So even though hydrogen is on the metal side, the compounds it forms are generally covalent. And then before we kind of stop the notes, I want to say one thing about the warm-up. So what you're going to be looking at, why do we look at least common multiples? Well, you're going to be looking at ions that have different charges. And when they form ionic compounds, the charge has to add up to 0. So if you had something that was plus 2 and you had something that was negative 4, does that add up to 0? No. If you have one of each of these, that adds up to negative 2, right? So what's the least common multiple of 2 and 4? Well, it's 4. So we need another ion that's plus 2 so that this adds up to 0. And that's basically how ionic compounds are formed. You need to find the least common multiple of the two charges of the ion, and then that will tell you how many you need of each ion in the formula. So this would be whatever this is. Let's say this is just some compound. Let me think of something that's not on the period. Let's say this is compound A. So we needed 2 ions of that, so it would be 2. And this is compound X, and there's only one of those. Now, chemists are lazy people, so if there's 2 of them, we don't write this subscript of 1. Alright, so I think if you work through the POGL, you read the directions that you can do this. Please take this seriously. If you look at it and you learn it on your own, it's going to be a big step towards learning how to do this. And then tomorrow, hopefully when I get back, or if I'm not out tomorrow, I'll help you on there. I don't know. And I don't know, maybe the sound on this was worse. Maybe you should have just turned off the sound at all. You didn't really need that. But that's it. I'm rambling. I'm signing off. Adios.